Okay, so now this is the review of Chapter 7 for the Chapter 7 test. Okay, so the first thing that you need to know is you need to find all the numbers for which the expression is undefined. Now, what does that mean? When the denominator is 0. Denominator is 0. If the denominator is 0, it's undefined. Undefined. So here's what we do. We take this, you never lose factoring. So the top part, anytime I do factoring, all I do is that when I have it done factored, I put it in parentheses. That tells me I'm done. In the numerator, x plus 7, there's nothing that I can do with it. Nothing I can do with that, it's x plus 7. On the bottom, the factors of negative 36 that add up to positive 5. Okay, so now, if I do that over here, the factors of negative 36 that add up to positive 5. Okay, now if I start to go through these, I've got this. Okay, well, negative 1 and 36 and 1 and negative 36. But that doesn't, when I add those together, I'm not getting 5. So now I've got to get numbers that are a little bit closer together. Well, it can't be 6 and 6, negative 6 and 6, because that's 0. So I can't get that. So now let's try a couple others. So what else? I could try 3 and 12. Well, when I add those together, nope, it still doesn't get it. So now what if I go negative 4 and 9? Well, when I add these together, I get 5. That's what I want. So those are my factors. X minus 4, x plus 9. Remember, you're using the signs. If there's no sign there, it's plus. Now, take each one of these things in the denominator and set them equal to 0. Take each one of the parentheses and set it equal to 0. Solve it. And then this is what you do. X cannot equal 4. Subtract 9. X cannot equal negative 9. And that is the symbol. That not can't it not equal, is that even correct English? It can equal 4 and it cannot equal negative 9. So the first thing that you're going to need to know on how to do, find all the numbers for what makes this expression, an expression doesn't have an equal sign, make that undefined, okay? You don't lose factoring. Simplify. Well, simplifying this rational expression just tells you I've got to factor. Okay, so let's factor this. Well, the top, x and x, I can't do anything with x squared except x and x. The factors of negative 3 that add up to positive 2. Plus 3 minus 1. Do this one down here. Well, x is just, or x squared is x and x. The factors of 2, now sometimes people get confused with it. The factors of 2 that add up to negative 3. Well, if a minus followed by a plus is a factoring pattern. Minus 1, minus 2. Now here's the giveaway too. If you have something on top, you're probably going to have it on the bottom. So now all you do is cancel. Cross things out. And you're left with x plus 3 over x minus 2. What can x never be? X can never be 2 when I add 2. Okay? Now you're not asked to find out what makes it undefined all the time, but if you are, make sure that you're able to set the denominator equal to 0. Great. Here's another simplify. Simplify means factor and then cross out. Look at the top. What's the GCF? Remember, greatest common factor. We don't lose that. What's the GCF of the top? Well, it's 4. 4 goes into each one of those. And I've got the same variable, x. So you take out the smallest exponent of the x. So take out a 4x. What are you left with? This is the GCF. What are you left with? Divide through by 4x, you're left with x. Divide this through by 4x, you're left with minus 5. Remember, you're dividing through each one of those things. Divide this by 4x. Divide this by 4x. And that's how you get the what's left. Okay? Now if I take a look at this. Well, this is easy, x and x. The factors of negative 5 that add up to negative 4, which is minus 5, and plus 1. But you knew you were going to have something like that in the parentheses, or something that is the GCF. Well, now cancel out. You're left with 4x over x plus 1. Please do not cross out the x's. If it's attached with an addition or subtraction sign, this is a group. Don't split up the group by canceling it out. This is your answer. Good. Simplification of rational expressions. But now, what if I'm asked to perform some sort of operation? Adding, subtracting, multiplying, dividing. By the way, they always start with multiplying and dividing because that's the easiest thing to do first. So, but remember my steps. Here's my steps. Multiplying and dividing, factor everything first. Factor everything first. Okay, let's take a look at it. Well, this is a factoring pattern. This is a factoring pattern. So this factors into x plus 4, x minus 4. Remember, perfect square with a minus in the middle. Well, on the bottom it's just 10. There's nothing I can do there. Times 5. And there's nothing I can do here. But again, I put it in parentheses to indicate it's done. I put it in parentheses to indicate to me it's finished. I factored it completely. Now, what do? I now cross cancel. So look at this. Boom, boom, gone. Now look at this. 5 goes into 5 once. 5 goes into 10 twice. Now, rewrite it with everything that you have. So on the top, I have x plus 4 times 1, which is just x plus 4, or x minus 4. Sorry about that. X minus 4 over 2. Multiplying. The first thing that you do is you factor everything. Okay? Next. Ooh, got a division. Division. Remember what I said about a division problem. You have to keep, change, flip. Keep the first fraction. Keep the first fraction. Change the sign. Division, change to multiplication. Flip the second fraction. Now it is a multiplication problem. Like that. Now remember what I said. So if you have division, keep, change, flip, and then factor everything. So I'm going to factor this first one. Well, I've got a GCF of 2. So I got this. X plus 4 over x minus 3, and there's nothing I can do with it. Notice I put it in parentheses. Do you have to put it in parentheses? No. I do to indicate I'm done. Times, well, look at this. Perfect square with a minus in the middle. So we know that's a factoring pattern. X plus 3, x minus 3. All over, take a look at this. Well, now this is one of those factoring things. Split it into two things, x and x. The factors of 4 that add up to 5, 4 and 1, plus 4, plus 1. Cool. Multiplication, now I look to cancel stuff out. I can cancel things out diagonally when I'm multiplying, or I can cancel them out up and down. So I got to look in both cases. Well, I got x plus 4, cool. I got x minus 3, cool. Take what's left. Now watch what I do. You got a 2 over here, 2 times x plus 3 over x plus 1. Now you don't have to do anything with this. At times, I may have you, when we're adding and subtracting, I may have you actually distribute that. But this is a good response. Okay? Ooh! Now we get into, you know what, I'm going to go to the next slide because I don't know why they did the subtraction before the addition, but I'm going to do the addition first. When you are adding fractions, you have to have a common denominator. If you don't, you got to make one, but you have to have a common denominator. Well, this is a common denominator. Well, this is good. All you have to do is to add the numerators. Add the numerators. So this is what I have. I'm just going to minus 2y squared plus 5 plus 6y minus 5 all over y plus 3. Now, combine like terms. Combine like terms. Well, I don't have anything here to combine with the exception of my plus 5 and minus 5. So I got minus 2y squared plus 6y. These cancel out over y plus 3. After you get done combining things, factor. Combine the numerators, get it down here. Now, factor. Look at the top part. If it starts with a negative, factor out a negative. So I'm going to factor out a negative 2y. They have a y in common. Take the y with the lowest exponent. And what do you have left? Well, I'm left with y minus 3. I don't know what that is. Over y plus 3. Can I cancel out the y minus and y plus 3? The answer is no. This is a good answer. Okay? If it starts with the negative, factor out the negative. But it changes all the signs. Notice it changes this. If I factor out a negative, this changes to minus. Okay? Next. Oh, no, I got to go back. Sorry about that. Now I got to go back to the subtraction because this has got its own unique skill set. So this is what I mean. This stays the same. Remember when you have a common denominator. I do. I have a common denominator. That's good. I have a common denominator. But now I've got this minus. If you have a minus, it changes all the signs that follow just to the numerator. Okay? So I have this. Y squared minus 2y plus 3. This numerator stays the same. We're all good. Minus y squared plus 4y plus 5. Notice, changed all the signs that followed. By the way, it's all over y squared plus 7y plus 12. Now, combine like terms. Well, look at this. Y squared minus y squared is canceled out. And if we look at this, I've got minus 2y plus 4y, which if I go across here is 2y plus 3 plus 5 is plus 8. All over y squared plus 7y plus 12. That's an 8. Okay. Now I'm going to factor to see if there's anything that I can actually simplify. So take out a 2 on top. You're left with y plus 4. On the bottom, this is y. The factors of 12 that add up to 7, which is 4 and 3. Y plus 4, y plus 3. This is the exact reason why you factor after you've combined like terms on top. You factor. Well, look what happens. Those cancel out. That's good. That's simplifying. And I'm left with the final answer of 2 over y plus 3. Okay? Okay. Now, if you just looked at this and you said, hey, what can y never be? It can never be negative 3 because negative 3 plus 3 is 0. That makes it undefined. You cannot be. Okay. What if you do not have a common denominator? Well, you better make one. You better make one. So what you do is you take all these denominators. What you're finding is the least common denominator, the LCD. The LCD. Now, there's nothing to factor here, so I don't have to factor anything out. So I've got this. My denominators, my LCD, I've got an x plus 3. Notice I'm putting that in parentheses because that's a term. And I've got x minus 3. And LCD says take these things, and with the highest exponent, but we're going to worry about that later, but take these things and multiply them together. That's my common denominator, x plus 3, x minus 3. X plus 3, x minus 3. You have to have them both represented. Now here's the twist. Here's what you do. How do you make this denominator look like this denominator? Well, you multiplied it by x minus 3. Whatever you do to the bottom, you have to do to the top. So you added an x minus 3. Not added, you multiplied it. So I'm going to do that to the top. I'm going to multiply that by x minus 3. Well, what about this one? You have an x minus 3. You multiplied an x plus 3. Whatever you do to the denominator, you must do to the numerator. Now let's multiply this out. Distribute. Now I know it's written a little differently, but I'm going to multiply x squared minus 3x over here 5x plus 15. Now I can go ahead and combine the numerator. So I have this x squared plus 2x plus 15 all over x plus 3, x minus 3. Because what I did is I said minus 3x plus 5x, which was plus 2x. I cannot factor that. This is the final answer. Okay? Next, so now I got to actually start reaching into a little bit more that, I'm not going to say complicated, but it does take a little bit of knowledge. This first fraction stays the same. That's good. 4 over x minus 3. But when you have something in reverse, I'm going to rewrite this, and I'm going to put it in the right order. Remember, you have the variables all the way to the constants. And when you're talking about variables, you go from the highest exponent to the lowest exponent, okay? So here's what I got. The x plus 5 stays on top. And this is minus x plus 3. I don't like that. I don't like this because it's got the minus leading. Remember, when you have a leading coefficient of minus, get that out. I'm going to factor out a negative. I'm going to factor out the negative of this denominator. This first thing stays the same. When I factor out a negative in the denominator, it changes the sign. It changes the sign. So the plus becomes a minus. This stays the same on top. You factored out a negative in the bottom. You don't do it to the top, you do it to the bottom. And you end up with x minus 3. Well, look at that. Look at this. I got a common denominator. So you just combine the numerators. 4 minus x plus 5 over x minus 3. What is that? What are you doing there, kid? What are you doing there, kid? I did 2 sets of parentheses. Losing my mind. Over x minus 3. Well, this turns out to be, I'm going to put it up here, minus x plus 9 over x minus 3. Now, you could leave it just like that. There's nothing more that you have to do. So you could leave it just like that. Okay? And daggone it. This is an error, by the way, because this should be a minus. This minus sign changes all. I don't even do the own rules that I tell you about. This should be a minus because this negative changes all the signs. So 4 minus 5, which is minus 1. So the answer is minus x minus 1 over x minus 3. Error, my part. My bad. Okay? But this negative, just so clarification, this negative changes all the signs that follow, minus x minus 5. Next, well, look at this, I got a 1. I would change any number to a fraction. So this is 1 over 1 plus 3 over x minus 1. Common denominator, I got to find a common denominator. Well, my common denominator is x minus 1. My common denominator is x minus 1. Well, this one over here is easy. Is there anything I have to do? You didn't do anything with this denominator, so I don't have to do anything with the numerator. I multiplied this by x minus 1, so you have to do it to the top, x minus 1. Distribute, well, it's just x minus 1. Well, now all I have to do is to add up the numerators. X minus 1 plus 3 over x minus 1. X plus 2 over x minus 1. So if you have just a number, put it as a fraction. That'll help you solve it. Oh, don't know why they threw a division 1 back in here, but they did. So I'm going to rewrite this, x minus 1 squared. First thing I'm going to do is keep, change, flip. Keep, change, flip. Now I'm going to start to factor, but with this top part, this isn't factoring. You're not going to factor out, but you're going to expand it. So it's going to look like this. X minus 1 squared is the same thing as saying x minus 1, or x minus y, times x minus y. You just write it twice. Okay? If it's x minus 1 squared, you write it twice. Over x plus y, there's nothing to do with this. It's already factored. What is the GCF of this? 3. And you're left with x plus y. That GCF is 3, you factor that out. What is the GCF down here? Well, they have a letter in common, it's x, the smallest exponent of the x, which is 1. Take the x out, and you're left with x minus y. Well, look at this. There's things that I can cancel out. Boom, 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 and what's left is 3x minus y over x. What can x never be? 0. Just set it equal to 0. All right, solve the equation. Solve the equation. You have to have, once you get a common denominator, you kill the denominators, okay? So my common denominator, now this is what I would do. This is 5 over x plus 2 over 3 is equal to 2 over 1 minus 2 over x minus 6 over 1. Notice, I just made fractions of all the numbers. That's what I did. Now I take all these denominators and I have to find the LCD. So I have an x, I have a 3, and I don't duplicate the x. As long as they have the same exponent, for an LCD, you take the highest exponent, but these have the same. So I'll just leave it like that. And you multiply these things together. So my LCD is, well, don't leave it as 3x, is the LCD is, or don't leave it as x3, put it as 3x. These are all of my denominators. That is what I have to do. Now you can see in the book that they do it a little differently than this. I think that this thing keeps it organized because I'm asking myself the same question. How do you get from this denominator to this? Well, you multiply it by 3, so you multiply the top by 3, which is 15. How do you get from this denominator to this? Well, you have to multiply it by x, so you multiply the top, so that's 2x. is equal to, what do you multiply this by to get to this? Well, you got to multiply by the whole thing. Times 3x, which is 6x. Whatever you do to the bottom, you got to do to the top. What do you multiply this? You multiply it by 3, which is 6. What do you multiply this? Well, it's the whole 3x, which gives you 18x. Cool. Now, this looks crazy. This looks nuts. Now, take out the denominator and solve the algebra problem. So I have 15 plus 2x is equal to 6x minus 6 minus 18x. Now all I'm doing is solving an algebra problem. Collecting like terms. Well, the first thing stays the same. I'm going to put this over here. This is 15 plus 2x. Combine like terms, which is minus equals minus 12x minus 6. Now I'm going to maneuver some stuff. So I'm going to add 12x to get 15 plus 14x is equal to negative 6. I'm going to put it up here. 15 plus 14x is equal to negative 6. Subtract 15 to get 14x is equal to negative 21. Divide by 14. X is equal to negative 21 fourteenths. Now you don't need to reduce this unless it says to reduce it, but you don't need to reduce this thing just the way that it looks right now, because it doesn't say to do any sort of reduction. Okay. I just want to make sure that I am I'm going to come back to this one in just a second. I'm not happy with this. Okay, next. 2 over x minus 1 is equal to 3, and I'm going to factor this, x plus 1, x minus 1, plus 1 over 1. My LCD, take everything that you see, which is x plus 1, x minus 1. That's my LCD. So my LCD is x plus 1, x minus 1. X plus 1, x minus 1. X plus 1, x minus 1. What do you multiply this by? Well, it's missing an x plus 1. Distribute 2x plus 2. There's nothing to do here. It's got the denominator. That's good. This I got to multiply by the whole thing. I got to multiply this by the whole thing. But remember what the whole thing was. If I FOIL this, the whole thing was x squared minus 1. I just did 2 steps in one right there. This I have to multiply by x plus 1, x minus 1. But if I FOIL this, I get x squared minus 1. Eliminate the denominators, drop them off. So I got this 2x plus 2 is equal to 3 plus x squared minus 1. I've got to set this equal to 0 and solve. So I'm going to move things around. I'm going to move some stuff around. I'm going to keep the x squared positive, but I'm going to move stuff around. So I'm going to subtract 2x. So I have this. And I'm going to subtract 2, by the way. So I'm going to put it over here. Hopefully you can see this. So now I have 0 is equal to, well, by the way, 1 minus 1. 3 minus 2 is 1. 1 minus 1 is 0. Those cancel out. And I have x squared minus 2x. Factor out an x. And I'm left with this. Set them each equal to 0. X is equal to 0 and x is equal to 2. Okay? So that gives you an indication as far as on what you have to do with some of these things. And that is the review. I may be back because I'm going to look at that other one for a second, and I may be back.